All right, good morning, everyone. We are going to go ahead and get started on our math lesson. So if you would please grab your enVision workbook, your big workbook. This is enVision Math 2.0, and we are on page 26. So if you'll open it to page 26, and on 26, it's showing you a picture of some posters. Libby has a poster, Sydney has a poster, and we're going to talk about, the question is, does order matter when you multiply? What that means is, if I have 3 groups of 5 equal 15, can I also just say 5 groups of 3 equals 15? So that's what this lesson is going to be about. We've talked about it several times, and so I'm excited to finally get to it because we've talked about it over the last week or two. So let's go ahead and have your book open to page 26. Pause this video if you need to have a little time to get that. And then when you're ready, we're going to come over and start watching the video that goes with our math program.
Does order matter when you multiply? Let's see. Libby and Sydney both say their poster has more stickers. Which poster has more stickers?
Okay, so let's look at both of the posters. Okay, they have some of the same stickers. I can see some of the same dogs, some of the same cats. Libby's poster has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 stickers on it. And Sydney's poster has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it sounds like they both have 12 stickers on their poster. They just look different.
You can multiply to find out. On Libby's poster, there are 4 rows with 3 stickers in each row. There are 2 ways to write this.
Remember, an array shows objects in equal rows.
3 plus 3 plus 3 plus 3 equals 12. And 4 times 3 equals 12. On Sydney's poster, there are 3 rows with 4 stickers in each row. There are 2 ways to write this. 4 plus 4 plus 4 equals 12. And 3 times 4 equals 12. Both posters have the same number of images. Did the order of the factors change?
Okay, so they both have 12. Did the order of the factors, so the factors are 4 and 3 and 3 and 4, did the order that they come in the problem change? Okay, so they've changed spots. This time the array, this is 4 down, 3 across, and this one is 3 down, 4 across. So they both equal the same, but the factors are in a different order.
Yes. The commutative order property of multiplication says you can multiply numbers in any order and the product is the same. So 3 times 4 equals 4 times 3.
And it means just that they're equal. They mean the same things. It might look different though. That's something we'll be paying attention to. So does 4 groups of 3 look exactly the same as 3 groups of 4? No. In 4 groups of 3, you'll have 4 rows, and in 3 groups of 4, you'll have 3 rows. So it will look different depending on what you were counting. All right, let's go to our convince me really quick. And that's at the bottom of page 26.
Circle the pair of equations that shows the commutative property of multiplication. Explain your answer.
Okay, so looking here, 2 times 4 equals 8. 2 times 8 equals 16. Does that pair of equations show commutative property? If it does, circle it. If not, don't circle it. Okay, 2 times 4 equals 8, and 4 times 2 equals 8. Does that show the same numbers and the same answer? Circle it if yes, leave it blank if no. 2 plus 2 plus 2 plus 2 equals 8. 4 times 2 equals 8? Are those showing the same answers? All right, so go ahead and write in your book and tell us what you think. And then we're going to be correcting it together. Okay, so I'm going to go grab the ImageMate camera. All right, so we are on page 26, down at the bottom. And it says, convince me, circle the pair of equations that show the commutative property of multiplication. That's what we're looking for right here. Okay, explain your answer. 2 groups of 4 equals 8, and 2 groups of 8 equals 16. Does that have commutative property? No. 2 groups of 4 equals 8, and 4 groups of 2 equals 8. Well, we've just switched the factors, and we have the same product, so yes, that works. And then 2 plus 2 plus 2 plus 2 equals 8. 4 groups of 2 equals 8. Well, this is showing me 4 groups of 2, but this is addition. And we're talking about the commutative property of multiplication. So this one won't work either. Okay? So why does that one work? Okay, because it doesn't matter which factor is first. Okay, so if you need to freeze it, go ahead and freeze it. Come down and write that down. And then when you're finished, meet me over on page 27. All right, on page 27, we are going to start on our guided practice. Do you understand? Complete the following statement. 6 groups of 4 equals 24. So 4 groups of 6 equals 24. Number 2 says, what multiplication fact can be paired with 2 times 8 equals 16 to make a pair of facts showing the commutative property of multiplication? So we already see 2 groups of 8 equals 16. So now we can do 8 groups of 2 equals 16. Okay? So 2 groups of 8 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 2 and 8. Okay? And this one is showing 8 groups of 2. So we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Did you see that? Oop, oop, let me get over there. Okay, so there's 8 groups of 2. Why is the commutative property of multiplication sometimes called the order property? Okay, why is it sometimes called the order property? Okay, so sometimes commutative property is called the order property. All right, so hopefully you have enough time to get that down. All right, let's go to number 4. In number 4, draw an array to give the product for each fact. Okay, we have 5 groups of 2 equal something, and 2 groups of 5 equal something. So we're going to draw an array. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's 5 groups of 2. that's 2, 4, 6, 8, 10. This one is 2 groups of 5. 2, 3, 4, 5, 2, 3, 4, and 5. 2, 4, 6, 8, 10. They're both 10. Okay, take your time to get that written down. Okay, number 5 and 6, we have 5 groups of 2 is the same as or equal to 2 groups of 5. It doesn't matter which order, we can flip it around and it will both equal 10. 6 groups of 1 is equal to 1 group of 6. You can just flop those factors to either side and they will still have the same answer if you keep the same factors. Okay, we're going to go to number 7 and 8. It says write a multiplication equation for each array in the pair. So I'm going to look here. 1, 2, 3, 4, 5, 6 groups of, how big are the groups? 2. 2, 4, 6, 8, 10, 12. Okay, let's go to this one. We have 2 groups of 1, 2, 3, 4, 5, 6. Okay, 2 times 6 is 12 and 6 times 2 is 12. Number 8. 1, 2, 3, 4, 5 groups of 1, 2, 3, 4. 5 groups of 4. 4, 8, 12, 16, 20. Okay. 1, 2, 3, 4 groups of 1, 2, 3, 4, 5. Okay. 4 groups of 5 is 5, 10, 15, 20. These two are equal. Okay, let's go to number 9. Draw an array to show each equation and write the products. Remember, this is the product, the answer. So the first one, 5 groups. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 2, 3, 4, 5. 2, 3, 4, 5. 2, 3, 4, 5. Okay. So we have 5 rows of 6 in each row. That's 5, 10, 15, 20, 25, 30. Okay. 6 groups we have. 1, 2, 3, 4, 5, 6 times 5. 1, 2, 3, 4, 5. Okay. So we have 6 groups of 5. 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Oh. I wrote a word instead of that. Okay. So when we count this, 6 groups of 5. 5, 10, 15, 20, 25, 30. They're both equal. I should just erase that because I made a little mistake. All right. All right, it's not going to come off all the way. Okay, numbers 10 through 12 says fill in the missing number. So the first one says, if 5 times 3 equals 15, then blank times 5 equals 15. 3. If 8 times blank equals 32, then 4 times 8 equals 32. Blank times 6 is equal to 6 times 7. Okay? So 6 times 7, 7's here, so that means that has to be 7. And 1, 2, 3, 4, 5, 6. 6 times 7. Could do a lot of these rows here. Okay. I think you have that all down. Go ahead and turn the page to page 28. See if I can get this over here. 28. Okay. Effie earns $26 from babysitting and $45 from mowing lawns. She spends $12 on lunch. How much money does Effie have now? Okay. So she earns $26 from babysitting and $45 from mowing. So let's add those together. Okay, number 14. Chen arranges 32 berries in the array below. What other array can be used to show the same number of berries? So this one has 4 groups of 3, 4, 5, 6, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6, 7, 8. Excuse me, I had 8. Okay, so we have 4 groups of 8 or 8 groups of 4. They both equal 32. Okay, what other array can he use to show the same number of berries? So instead of 4 this way, he can do 8. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 6, 7, 8. Okay. One more set. 1, 2, 3, 4, 5, 6, 7, and 8. So there's an 8 by 4, which goes with that one right there. Okay. Number 15 says, Raymond says he can use the commutative property of multiplication to show the product of 4 times 6 is the same as, excuse me, let me read it again. The product of 4 times 6 is the same as the product of 3 times 8. Is he correct? Why or why not? Okay, let's start with 4 times 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. Okay, so I have 4 rows of 6. Let's do 3 rows of 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there's 3 groups of 8. Okay, let's look at it again. Ramon says he can use commutative property of multiplication to show the product of 4 times 6 is the same as the product of 3 times 8. Is he correct? Why or why not? So he proved it by showing us the diagram, the bar diagram, or the counters, but are they the same? Is he correct? Why or why not? What do you think? Ooh, Mrs. Martinez lost her book. Hang on one second for me to get it. Well, that'll make everybody pay attention, right? Okay, we're back. All right, let me go back to our camera. Okay, we're back. Okay. So Ramon says he can use commutative property of multiplication to show the product of 4 times 6 is the same as the product of 3 times 8. So 4 times 6 is 24, and 3 times 8 is 24. Are they the same? The products are the same, but the factors are not. But the products are the same. The answer is the same. Okay, go ahead and pause if you need to. Get that written down. And then number 16 says, fill in the blanks. You can show the commutative property of multiplication using two arrays. The number of rows in the first array is equal to the number of columns, because that's the parts that go across. So here's the row and here's the column, okay? In the second array, the number of columns in the first array is equal to the number of rows in the second array. Can you see that one? Let me see if I can. This erasable pen here that comes in handy sometimes. Okay? Oop, not an ES, just an S. I think Mrs. Martinez is tired. Okay, number 17. How did the arrays at the right show the commutative property of multiplication? So we have 1, 2, 3, 4 groups of 1, 2, 3, 4, 5, 6, 7. So we have 4 groups of 7, and that's 7, 14, 20, 128, okay? And then this side we have 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. 7 groups of 4 is 28. Yes, they show that. Okay, yes, they show commutative property. All right, so make sure you get everything written down in your book. Go back in this video if you need to look at things. We're going to go over our homework real quick so that you can work on that tonight, and then we're going to correct it tomorrow. And that will be it for our math lessons. After we correct tomorrow and do our interactive notebook, you're all done for the week. So try really hard on this. It can be pretty fun too. So let's take another look. It says, this array shows 2 rows of 3 pennies. 2 groups of 3 is 6. And this array shows 3 rows of 2 pennies. 3 groups of 2 equals 6. You can use commutative property of multiplication to multiply the numbers in any order. You can do 2 first or 3 first. 3 first or 2 first. So numbers 1 through 2, it says draw an array first of all, and then you're going to write the answer. Okay, so we need the answer right here. I'm going to draw an array down here. Draw an array right below, and then we need the answer. Okay. Numbers 3 through 10 complete each multiplication equation. You may use counters or pictures or draw pictures to help. That's what I would suggest. You could draw pictures. You may not have room here, so you can get a piece of scratch paper. But you're looking at numbers 3 through 10. So 3 times 4 equals 12. So just the opposite. 4 times 3 equals 12. 5 times 2 equals 10. So 2 times blank equals 10. Okay. Hopefully you get the idea of that one. If you have any questions, please let me know. Okay. Number 11 on page 30. Use the commutative property of multiplication to draw the second array. Complete the multiplication equation. You're going to draw the second one. So this one's 7 groups of 3. 7 groups of 3. What could the other one be? Then you're going to count them up and add them up and put the products there. Okay. Number 12 says, Scott puts some sports stickers in rows. He makes 6 rows with 5 stickers in each row. If he puts the same number of stickers in 5 equal rows, how many stickers would be in each row? How do you know? Okay, so he puts some sports stickers in a row, and he makes 6 rows with the 5 stickers in each. If he puts the same number of stickers in 5 equal rows, how many stickers would be in each row? Okay, how do you know? So you're explaining your commutative property. Number 13 says, Karen arranges 24 star stickers in the array shown below. What other array could the same number of stickers be arranged in? So this one is in the arranged 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay, how could you get that child's answer up to 24? What's another way you could do that? Okay, number 14. Ed arranged some tiles in different arrays. One array has 3 rows with 6 tiles in each row. The other array has 2 rows with 9 tiles in each row. Ed says that he can use the commutative property to show that the arrays both have 18 tiles. Is he correct? Why or why not? And explain. Okay, 3 rows of 6 tiles and 2 rows of 9 tiles. Think on that one. And then the last one, number 15. Taylor made these arrays to show the commutative property of multiplication. Is that what the arrays show? Why or why not? So this is actually an array, and so is this. It's just a way of writing out your numbers. Make sure they're even. So we have 2 groups of 1, 2, 3, 4, 5, 6. And this is 1, 2, 3, 4 groups of 1, 2, 3. See if you come up with the same product, the same answer, and what does the array help you do? The second array. All right, guys, that is our lesson for today. Tomorrow we are going to correct, so make sure that you have gotten all of your work done today so that it will make sense for you. So tomorrow we're going to correct our homework, and then we're going to do our interactive notebook. All right, guys. Thank you so much, and I will see you in the next activity.